So the 2009 is a non-calculator, and it gives you the function rules, and it says find the area of R. Now, you could have gone from 0 to 2 and done top to bottom, which would have been 2x minus x squared. I decided to do one with the y intervals just so you'd have some experience in it. You'll get the same answer. So I did 0 to 4. I converted this to square root of y, and I converted this to 1/2 y. So I'm doing right to left. So I'm doing the square root of x minus 1/2 y. And then you're doing this manually. So if you do your power rule on each of these and plug in, you get 4/3. Now again, you could have done 0 to 2. You would have done top to bottom, so you would have said 2x minus x squared, and you would have gotten the same answer. Now part B says the region is a base of a solid. The cross-section perpendicular to the x-axis has area of sine pi over 2x. Find the volume of the solid. So they've already given you the area of the function. And so in this case, then you're just going to go 0 to 2 sine of pi over 2x. Because remember, with cross-section, we do the integral of the area, and we usually use the difference in the two to get it, but in this case, they just gave it to you. Since it's perpendicular to the x-axis, we're using x intervals. Now, you have to do this manually, so you've got to go u equal pi over 2x, du equal pi 2. So we're going to negate it with 2 over pi. And then the integral of sine is negative cosine. And we put our input values in. So if I do 2 here, I get cosine of pi, which is negative 1. And then if I put 0 here, it's 1. And so if you work that out, you get positive 4 pi. Now part C, you have another solid. The cross-section perpendicular to the y-action are squares. So if it says perpendicular to the y-axis, you're going to use x equal equations. You're going to use y integrals, and you're going to move from right to left. So you're going to use the equations that I converted in part A. So I already have them. So I just do square root of y minus 1/2 y. So that's the length of our square squared, because the area of a square is side squared. And again, we went from 0 to 4. So the 2009 Form B is another one where there are no calculators allowed. It gives you the function rules, find the area of R. And in this one, you could do top to bottom. So you'll go 0 to 4, square root of x minus x over 2 dx. And again, you'll have to do your power rules, plug your values in, and you get 4/3. Now, part B says the region R is a base of solid. The cross-sections perpendicular to the x-axis are squares. Find the volume. So you know that the difference in the functions is the side of the square. The area of the square is side squared. So you just go 0 to 4, that. Now, the problem on this one is it's manual. So you got to foil this out so you can do your power rule. So you can see I messed up on my foil and I had to go back and do it again. So if I do x 1/2 times x 1/2, it'll be x. And then x 1/2 times minus 1/2 x, you'll get 2 of those. And you'll get negative x 3/2. And then negative x over 2 times negative x over 2 will be x squared over 4. So then you'll just separately do all your power rules on that. Plug your values. Now this is kind of a crappy one with a non-calculator because the fractions are kind of ugly, but you'll have to get a common denominator, and you can just, if you're actually on the exam, do it on the side of your paper so you can get it. And if you get all that, you'll get 8 over 15 if you add 8 minus 64 fifths plus 64 twelfths. So what I did here is I did these two first and then did these two. So again, you had some ugly numbers, but you can do it. And then it says write but do not evaluate an integral for the volume of the solid generated when r is rotated about the horizontal line y equal 2. So remember, we're going over a line. So the bottom becomes the top, and we do the line minus the function rule. So when you come in here, you're going to say 2 minus x over 2 squared minus 2 minus square root of x squared. So it's the line minus the function rule, and then your pi's on the outside. Now the 2008 one in your notebook, you can use a graphing calculator. They give you the function rules, and they give you the drawing, and it says find the area. These little marks I've got on it are for the you do later in the problem. So the first part, we're just doing the sine curve minus the x cubed minus 4x, and you're going from 0 to 2, so you're going top to bottom, and you can use Math 9 and you get 4. Now it says the horizontal line y equal negative 2, which is right here, splits the region into two parts. Write but do not evaluate an integral for the area of part r that is below the horizontal line. So the first thing you got to do is you're going to put in your calculator y equal negative 2, and you'll have this function right here, y equal x cubed minus 4x, and you want to find their intersections. So when you do that, that point is the x coordinate is 0.53918887, and the other intersection x coordinate is 1.6751309. So you're talking about writing an expression for the part r below the horizontal line. So this is your top curve, y equal negative 2 now, and this is your bottom curve. So you're going to come down here, you're going to go from your two intersecting points, because that's your integral, and you're going to do negative 2 minus this dx, and that'll give you an integral for the area, because remember, it's just top minus bottom. So part C, the region is the base of a solid. Its cross-section to the x-axis is a square. Find the volume. So remember, you're going to have the difference in the curves be the side of your square, and then you're going to take the area of it. And so you're back to 0 to sine of pi x minus this squared dx, and you do Math 9, and you get 9.978. Now part D says region R models the surface of a pond. At all points R at a distance x from the y-axis, the depth of the water is given by 3 minus x. Find the volume of the water in the pond. So think what volume is: length times width times height. So basically what you're doing is you're doing the depth, which is the height, times the length minus the width, because that's what that is. So we're just going from 0 to 2. We put that in, and then what we already had, and you get, use Math 9, you get 8.369. So think about that. You're saying at all points, distance x from the x-axis is the depth, and then the difference between the two would be the area. So area times height is volume.